So once again, namaste everybody. From Kathmandu University School of Education, it's me Indramani Shrestha, working as a full-time faculty in the Department of STEM Education, Kathmandu University. And as this Kusod webinar series is the seventh one of this year, it actually goes on every year with some gap of time. And up till now, seven series, as I told you, seven series has been already gone, and it always starts at 5 p.m. every Friday. And whoever newcomers come here, you can invite other people who are interested in learning the new pedagogical approaches that is being practiced all over the world. And in this Kusod webinar series, we invite different people, experts, and personalities, educationists, as well as our students who are doing their PhD, MPhil, Masters, PGD, and who are not who will be no, who will not only be sharing the theoretical perspective. Rather, we encourage all the presenters to share their experiences and how theory and philosophical perspective can be implemented in the real world situation. So, in this regard, today we have altogether two presenters. One is Mr. Premraj Joshi, who has just finished his Master in Mathematics Education, and he has already done Master in Physics, I think, yes, sir? MSc in Physics.
Yes, sir. Yes, sir.
MSc in Physics, and he is currently teaching in one of the reputed schools out there in the Sudur Pasim, sir.
Yes, sir.
Yes, Sudur Pasim. And another one is Mr. Harisaran Pandit, who is PGD scholar from Kathmandu University, and he is currently teaching mathematics in Buranilokante School. He has also already done his master's in mathematics education. And both of these two presenters have long experiences regarding teaching mathematics and sciences. And today they are going to share their ideas about the experiences about science as well as assessment in learning, assessment for learning. And in this regard, first of all, I would like to invite Mr. Premraj Joshi to share his slides. Before that, here I can see our respected Dean, Professor Balchandra Luitel sir, and I would like to request him to say a few words regarding this webinar, and then
सर म अहिले धेरै नबोल्नु यो बोल्न सक्ने उसमा छैन प्लिज कन्टिन्यू है त
okay, thank you very much, sir. He is not feeling well. That's why now I request Premraj Joshi, sir, to continue. Please share your slides. You
Yes,
will
sir.
have 20 minutes of time for the presentation, and 10 minutes time will be for the question and answer. And I request all the valued participants to put to write your questions in the chat box so that we can have a discussion after the presentation. Thank you.
So, hello everyone. First of all, namaste to all of you. Now I'm sliding my screen. Is my screen visible, sir?
Yes, please. Please start.
First of all, thank you very much to the Kathmandu University for providing this platform to me. Today, the topic of my presentation is teaching science in secondary level using the PhET simulation. Actually, this is the action research which I have conducted, for the in the MATPT fellowship, during the MATPT fellowship, which was just finished few months ago. And Indramani sir already introduced me. I was the past student of MAD in Mathematics Education from the Kathmandu University. So my presentation will flow, starting from the basic introduction to the PhET simulation. Then I will, show some demonstrates, few examples of PhET simulations, by going into the website of this PhET simulation. And in my third part, I will talk about, about my experiences of the action research which I have done, during that fellowship. Let me move toward. First of all, before knowing about the PhET simulation, let us know what is the simulation. I hope all of us, we know about the simulation, about the word. The simulation word just means that, it is the modeling of the real system, right? So whatever is happening around us in our surrounding, when we model it, when we program it in the form of some digital, like software or digital any mobile apps like that. So basically that is the simulation. So if you look at the example in the figure at the lower bottom side represents the projectile motion, right? And this is one of the simulation. Similarly, this is the solar system. This is also a type of solar, this simulation. So simulation just implies that, we are programming, or we are modeling the real system. So basically, why we are doing the, why we actually do the simulation means, it actually provides visualization, and sometimes it's very difficult to really do the experiment and all, because of the many things, right? So they are due because of the cost expensiveness and all. So simulation, I will also talk about its advantage in my later slides. Now let me go to the PhET simulation. What actually is the PhET simulation? PhET simulation just implies, it's the acronym of the physics education technology. And actually this is the simulation website. This simulations was founded by the Nobel laureate Carl Wyman in 2002, under this University of Colorado Boulder. Basically, these simulations are very free and interactive. Basically, it although it by its name, majority of the simulations are from the physics, but along with that, it also consists the various simulations of the chemistry, biology, and few simulations of the mathematics also. We will go to that website also. I will show there. So basically, the motive behind this starting, or behind this starting this PhET simulation was, to engage the students through, through the digital tools. And like, there are so many games, students can actually able to learn from the games. And it is completely free. We do not require to pay anything, right? Because other so many website or software, we sometimes we need to pay something for that. But it's completely free. That's open educational resources, we can say. When we, this is the website. If you can explore later, www.fet.colorado.edu. And this is the first interface. If we click on this website, we will see this kind of thing. And uh, I will show little bit about this. My screen is visible, sir? Hello?
Yes, sir. Please, please.
Okay. So this is the website. And if we scroll down, if we look at the top, there are four icons, basically simulations. There are so many simulation, like physics, chemistry, math, or science, biology, and all. There are some teaching resources also. There are some activities, some research related, and other thing also there. You can explore later. So there are so many. If you want to, like to visit, like to explore the simulations of the physics subject, you just click over here and it will show that simulations. Similarly, and there are other things also you can explore by your own later. So when you click it, there will be so many simulations. You will see here, you can see that this physics related simulations over here, right? So okay, so I, for just for example, I have taken this one example. This is also there. Uh, there are about 54 simulations for the physics subject, and in total I think by combining physics, chemistry and all, consist about 105 simulations, right? So there are so many simulations you can explore by your own. For just for now I have chosen a simulation of pH scale. If you scroll down, it's under the chemistry branch. Basically, if you see here, we generally teach our student about the pH scale in, probably in 8th class or ninth class maybe. So and when we actually teach them, sometimes they may confused about, what's this pH scale, what's the what happen when acidic solution, what happen when there is basic solution and all. So this is very simple simulation actually. So this is the pH meter and this is the meter, I think. This is the meter, and this is the water. This is the pump. You can eject. First of all, you can eject the pump from here, and this is by clicking here you can just insert the water into this jar. And if you want to remove the water, you can just, if you click on here, the water will drops down. And if you do not require water, you can completely exit out the water. And likewise from here you can add different type of the solution like battery acid, blood, chicken soup, coffee, and there's soda pop. There's so many. For example, this orange juice, if you click here like orange juice, and if you press here, it will filled, the orange juice will be filled, right? Orange juice will be filled. And if we want to know the pH scale of this solution of this juice, if we click here, it's the pH value is 3.50 and it is acidic. So likewise there are some various examples, right? So there are so many examples the students can explore by their own, also by their own, if we able to motivate them. So what happen by this, what happens, if we try to do, yes, obviously the practical activities are very good, they are necessary, but sometimes what happen, because of the various reasons, we not able to conduct so many experiments and lab based activities in teaching science. And and again, in if we try to do in lab, it's very difficult to collect all these solutions at a time, right? But as it is the digital tool, we can choose any type of the solution and we can fill it here. We can add water into this, right? If we add water into this now, if we note the meat, this its pH, its value increases. Now we can we can discuss in the class why the pH value increases if we add the water and if we eject the water. And so many interaction can be done in a class, right, from just by this simulation. So likewise I just want to demonstrate another simulation. If we you can just find this from here. If you can just scroll down here, and if you click, and you will directly go to there. But I have already opened it because it takes some time. So this is another example, right? This is another example of chemistry. Basically students feel very very confusion while to know about the atom, how the atom made, how, what is the nucleus, right? What are the proton, neutron, and all so many things, because that is because students not able to visualize, what happens if we increase the proton, what happens if we decrease the neutron and all. So what happens in this case, from if you look at to this simulation, basically for lower class we do not need this half life and available decays for its for basically 11th and 12th class. But for the smaller grade, like for 8th or 9th, just proton neutron and this symbol is quite enough, I think. So what we can do, we just take one proton from here, we can just, and it is hydrogen. Now its symbol is H11. Now if we add one neutron to this, it is still hydrogen, but it consists of one neutron, so its symbol will be 1H2. Now now if we add another proton to this, now what happens, it becomes helium, because it has the two protons now, and but still there is one neutron, so that's why two proton and one neutron in total, this number is represent the total. So in this way we can add so many protons, so many neutrons, and we can perform so many interactions on that, right? If we and students also able to they can also explore so many examples in their computer, in their mobiles, at the home also. So, and again, one more interesting thing is that there are some simulations which also offers the game at the last. I not pick up that one here, but it also has so many games based. So student, after knowing that, students perform that game, and the game shows the scores, and from that scores student actually motivated. And there are so many digital tools nowadays. The school students are mostly, they are engaged in the mobile and computers, and they are just doing so many games and all activities, and they are not interested in this type of study. But if we able to engage our students through the digital tools like that, this is just the example PhET simulation. There are other simulation methods also, from which we can teach our student there. You can explore by your own. So now I'm stop here, and now I'm moving toward my other part of the presentation. So okay, my screen is visible, sir?
Yes, yes, yes. Please
Okay.
go on.
Okay. Thank you, sir. Okay. Now I have already, explored this, how we can do the this kind of thing, and you can also explore these simulations over there. And if you if you want to implement this, PhET simulation in your class, and if you want to know about this PhET simulation, you can directly contact me also. So. The I previously I also talked about this advantages of simulations. Basically, this is just the PhET simulation is one example. Along with PhET simulation, there are several other form of the simulations also. Some are in the paid version and some are free also. So basically, it offers simulations. Basically, offers interaction. I already showed you, because if we teach in abstract way, we cannot do so many kind of discussion, right? And even in the lab based activities we have 2 or 3 solutions, but here we can have 10 or 15 solutions, and we can perform within 5 or 10 minutes, right? So again, the important thing is the visualization and less time consumption. Student actually visualize, and even in the very short time. But in case of lab based activities, it consumes some time. We just it takes some time to to set up the apparatus and all. Also the cost, from the cost perspective also, it is cost effective. There are no any kind of risk, we can say, and supplement practical works. But I'm not saying that we are replacing the practical works, because to offer the hands-on experience, to gain the skills, the lab-based activities and practical works are necessary. But we can say that if sometimes, if all the practical works are not possible, it can be a supplementary one. And now I'm moving toward my third section, in which I'm talking about the action research which I have done in the fellowship. This fellowship was about for about 1 year, which was just finished right just 1 month ago. And in this so before going to the action research, I just give some basic definition of the action research. So action research is very popular in basically in schools also. Action research means action oriented research. There is some action, there is some interventions, and whose effect and whose implications we are looking about. So it's basically it's a famous cycle. Firstly, to conduct the action research, we should have some planning, and then we actually act that, we perform that, and we observe its implications and reflect and again replan. So it continues. So basically its major motivation is to improve ourselves, to improve our current practices. For example, I just taken one example. For example, if we want to apply the project based learning method in our classroom, if this method is very new for us, so what we do, this can be a one intervention, and we have to know, we have to understand the effectiveness of the project based method. So we should plan, from the PBL method, we act, we perform by this method, we observe, various observation in the classroom, we reflection, we made the reflection and again replan, by which our day to day classroom activities will be improved. So basically in this fellowship, this fellowship was MATPD fellowship. In this fellowship, basically, we were about 15 participants, 15 teacher educator from the Nepal, and likewise from the Maldives and Afghanistan. In total, it was a very big project which consists of 45 teacher educator from the three countries, and it was coordinated by the Tata Institute of Social Science, TISS Mumbai, and there are so many funding partners also. So for this action research, the science teachers were selected from five different schools of here far western region Dangadi, and the lesson plan were made collectively by by incorporating the PhET simulation, because we are just trying to see the effectiveness of the PhET simulation. That's why. And the classroom observation was done, the focus group discussion was done, and these are few pictures of where the teachers implemented simulation. Students are also doing these kind of simulations in the computers, and so responsive from the teachers after after they have used the PhET simulation. All these five teachers with whom I worked did not use PhET simulation in their science classroom before. So after using this for about 1 and 2 months, they replied that it's very helpful for the visualization of the concept, and there were no any kind of risk, and it's interactive. It's it is easier to engage our students if we able to incorporate the PhET simulation, and students also learn with the fun, and there was the kind of collaboration, and student can also do, and student also do at the home too. So I also had some focus group discussion with the students, and they said that it is quite funny, they do not feel bored, and they able to understand easily. And as it was it can be done in the mobile and computers, they really liked it. And I also observed some classrooms where students really enjoyed, and there was a quite there was a very good engagement of the student also. So major finding from this action research, where basically it's a very good, this PhET simulation can be a very good tool to engage our students in our learning, because the currently the major problem in our Nepalese context is basically to engage students are not focusing, students are not able to put their interest in the subject. But this can engage our students. Likewise, it can help to make the collaboration of the students, right? Basically, yeah, in study purpose, we see that there is some lack of collaboration among our students sometimes. So it also, because when I have visited some classroom, students actually they were perform the activities in the group, right? in the group of 3 4 students actually make conversation, and on the basis of that they are perform the activities. So I found that, we found that it help in collaboration. Likewise, students performance also increases as they are interested in the subject. Obviously it may leads to the improved students performance. And I already talk about this. It can supplement some lab based activities too. Finally, I just like to acknowledge my academic mentor, field mentor, and Tata Institute of Social Science, this SET fellowship. And actually, as I have, done the action research, these five teachers have actually implemented the FET simulation in classroom, in their science classroom. So I'm also overwhelmed to them. Also, I'm also thankful to them. Also, so thank you very much, sir.
Okay, thank you very much for your wonderful presentation as well as insightful contents that you have shared. Here I can see one question in the chat box. Amit Shrestha has asked, is FET available offline?
Yeah, offline means you have to if you can download it, right? You can download it, and then you can operate in it in offline also.
Okay.
Thank you, sir.
Okay, thanks.
So students can also use this one easily.
Yeah, the student can also use, sir. Yes, definitely.
Okay. So any questions, any curiosity, anybody? Okay, Sachin Paudel has asked one question, Prem sir. Can we develop simulations or develop projects we can get easily? के भन्नु?
mm, okay, can we develop? अब यो यसमा चाहिँ उसलाई फेटले नै बनाएको हो होइन। तर अब फेट सिमुलेसनलाई पनि अब विस्तार गर्नलाई त्यसले अब त्यहाँ हामीले जस्तो प्रोग्राम जानेका मान्छेहरू हुन्छ नि, कम्प्युटरमा एक्सपर्टहरू, त्यस्तोहरूले चाहिँ प्रोग्रामहरू डिजाइन गरेर त्यसले चाहिँ डोनेट गर्न सक्छन्। किनभने फेट चाहिँ आफैमा एउटा फ्रीली एभाइलेबल भए हुनाले त्यसमा कसैले प्रोग्राम बनाएर डोनेट चाहिँ गर्न सक्छ। अब वी क्यान डेभलप सिमुलेसन भने, तर अहिलेको लागि चाहिँ फेटबाट हामीले उसँग जो इनबिल्ड छ त्यही इनबिल्डलाई नै हामीले के अरे त्यसलाई नै युज गर्ने हो होइन। आफूले चाहिँ अब जस्तै अघि मैले जो पिएच स्केल भने नि, अब त्यसमा जति छ हामीले त्यही युज गर्नुपर्ने हुन्छ। जस्तै त्यसमा भएका लिक्विड्सहरू थिए नि 8 10 वटा, त्योभन्दा अरू चाहिँ हामीले युज गर्न मिल्दैन, किनभने त्यो इनबिल्ड त्यसमा बनाएको छ। अब त्यसलाई उ गर्नलाई अलिकति होला। ओके।
Okay,
ओके, डाउनलोड
I think
नेक्स्ट।
another. Can you read the question, sir? Thank you, sir. How to download it? Could you please show demo for
Okay.
it? Yeah, you can show. Yeah,
Is my screen visible, sir?
yeah, yeah. Please.
So, for example, just let's see this gravity force lab, right? If we click on this, uh, okay, if we click on here and okay, I think there is somewhere like there download option, I think. So here you can actually download also. Actually, not get it. Here this gravity force lab, and this there is the download option, right? And you can just download it. uh, it will be downloaded on your computer. And now if it is downloaded, now you can use it without the internet connection, because sometimes student, even in our some schools also, the internet is not available. So in that case, what we do, we can just download many these the simulation in our pen drive, and just take the pen drive in the computer, just put that, and just if you open this, it will be opened without internet connection, right? Is it fine, sir? Okay, sir.
Okay.
Okay. Thank you, sir.
Uh, okay, I think thank you, sir, for wonderful presentation. Okay, thank you very much, Premraj Joshi, sir. I think if you have any queries, you can also contact Premraj Joshi, sir. Prem, sir, you can leave your
Okay.
number as well as email here in the chat box so that interested people can contact you and get some ideas about this PhET
Sure,
solution.
sir. Sure, sure.
Okay, thank you very much
Welcome, sir. Thank
once
you.
again. And now I invite the next presenter to share his slides. Mr. Harisaran Pandit. Okay, his call has come here. Just a minute. Uh, just now, the next presenter has called me that the electricity has gone in his area. He will be joining very soon. He is trying to join through the data. So until then, we can have some discussion about this PhET solution. Also, it doesn't matter. Prem sir, can you show some other PhET solution? What that simulation?
Yes, sir. I
Some,
will. I
yeah,
will.
yeah. Until the another
Yes, sir. Sure,
presenter
sir.
comes.
Uh, okay. Due to the time limitation, I showed just two examples. So I will show you by step wise, right? So you can just for open this, you can just PhET colorado.edu. If you click this website web address, and it will be opened, and this is the home page, right? If you first open this, you will get this kind of link. And some one of the teacher also asked their question about the mathematics. Similarly, yeah, but there are not very large number of simulation of mathematics, but there are some, right? uh, okay, it is now opening. uh, Physics simulation, chemistry, earth biology, earth science and biology. Mm, okay. Okay, in math also there are so many simulations. There are about 46 simulations, right? Inbuilt simulations are there. So many things like this, this this ratio and proportion, let's say. Mm, okay, so the process is same in as in case of the other. So in this case also there are other so many various things, like, so we can we have some basic idea. There are the teaching resources also, right? There are the activities, but you have to sign in for this also. And I think that to download this also you may need to sign in. I'm not sure, but I think download you can download easily, but to get complete features you may have to sign in. So if you click here, in the same way, uh, it will open uh, in this way. But it may, if the internet is not very fast, it may take some time because it is loading. It takes time, I think, but it will open definitely. So here also this gravity lab, if you just this symbol, this play button here, we just need to click on this, right? It is about the Newton's law of gravitation. And let me, it also, it may still take time. So that's why I already opened these two one. um, Okay. So basically, have anybody used this PhET simulation before here? If you have used this, you can also share your experience. Yes. So basically, you know, as I have observed so many classes of, I saw that students were so much interested, because as this action research was conducted in 5 different schools. So actually students really enthusiastic towards learning, and as it is completed in the digital mode, they grasp it in a very short time, because nowadays the kids are very much fast in the digital technology and tools. So this can be helpful, I think. It will take time, I think, sir. It is not opening. Yes, sir. These all things are there. If you explore it, you will get. If you have some, if you want to implement in classroom, and if you want any kind of help, I will support. Yes, sir. Thank you. Should I stop, sir?
Okay.
Okay, sir. It
Kamal
is
sir,
taking some time for
Harisaran sir is back or not?
Yes, I'm here,
time.
sir.
Yeah, okay, yeah, we are waiting for you. Please share your slide and start your presentation. Okay, sir. 20
Yeah.
minutes time for you,
Okay.
and after that, 10 minutes time for the question and answer.
Okay. Okay. Thank you, Indra sir, and good afternoon to all. Uh, Good afternoon, Balchandra sir, and all faculty members and all friends. Today I'm going to present uh, a report on uh, why and how assessment for learning is essential for teachers. Uh, I'm going to present some slides. Okay. So my topic for today's presentation is assessment for learning strategy in mathematics instruction, teachers' perception and practices. First we begin with the simple meaning of assessment for learning. Uh, an approach that focuses on using assessment to improve learning, and from other angle we can define it as an approach to teaching and learning that creates feedback which is then used to improve students performance. And in assessment for learning, students get actively involved in the learning process and gain confidence on what they are expected to learn and to what standard. Next, I'm going to another slide. Excuse me. Am I audible, sir?
Yes, please. Yes.
Okay, it's not working well. It's not working well. Okay,
Is it a video?
yeah,
I think in
okay,
you have a weak internet, maybe.
yeah, okay,
Once try. Otherwise, you can escape this one, and then
yeah,
later
okay,
on.
okay. Now it's working now.
Okay. Please
And
share your slide.
assessment for learning, is it visible, sir, now?
No, no, your slides are on share now. Please share the slides.
Oh, yeah, okay, okay, okay. Yes, it's okay now. Yeah, okay. So basically, what is the process during that assessment for learning? First, we try to find out where the learner is now, where the learner is going, and how to get there. So these basically three things should be kept in mind while working with assessment for learning. And next one is role of formative assessment and continuous feedback. Formative assessment involves providing feedback following an assessment, delivering or providing feedback during instruction, following instructors to identify students' misunderstanding and help them correct their mistakes and errors, identifying students' knowledge and skill gaps, developing teaching learning strategies for improvement. Next one is assessment for learning in mathematics instruction. This is a bit specialized in mathematics. Uh, my own experience and based on international practice of mathematics instruction, I have found that these five steps are performed by a teacher to make the class more effective and more useful. The first one is demonstration or derivation by induction or deduction and with lots of examples. Second one is the guided practice, where the teacher plays the role as a facilitator. The guided practice may include group work or peer work, and after completing the stage of guided practice, it would be better to go to independent practice for students to become independent in solving the problems. Then comes to a formative assessment and feedback, and there may be a cycle of formative assessment. We can take many assessments, two, three, four, five, as per the necessity. And at last, there is a summative assessment and final reporting. So far, I have found these five steps of assessment for learning in mathematics. At times, I have found that the summative assessment can also play a great role for developing teaching strategies for the next year or the next group. Okay, this is my finding, and here are some pics snapshot. I have just conducted an action research for assessment for learning in mathematics instruction. So these snapshot shows, for example, I have given a problem there on the board, and students are picked up randomly, or we can use the lottery also. And one student comes to solve the problem, and he or she begins the solution, the first step of the solution. Then second student comes and check the solution of the first, and if there is everything correct, then it proceeds the solution. Otherwise, first he or she corrects the solution given by the first, and upon the completion of the checking, then he or she goes forward, and until and unless the whole solution is completed, uh, once the answer is obtained, then other students are also asked to recheck the solution. Okay, this is one practice I have been doing since last 15 years in my math class. Okay, this is one practice, and we can do many other practices. They are also equally important and effective. uh, this this slide contains some experiential learning of some feedback given to learners during assessment for learning. A math problem of set and set operation of grade 10 was given to all students as ongoing assessment to check their learning status. All of them tried to solve the problem in their own way. Any four students, based on their performance, including all categories, were picked to solve the problem on the whiteboard. One had to draw the appropriate Venn diagram. Second had to check whether the diagram was correct, and if it was correct, then to proceed the solution using Venn diagram. Third had to check the solution given by the first and second. If correct, then to proceed, and the fourth had to follow the same process and in the solution. Or if they need more person, if the process needs more students, then we can add more student as well. The only motive is to get the solution by different students, and processing and checking at the same time. And during that teaching during this teaching method or teaching strategy, I got some of the critical points are, let's say, very important steps. If there was any problem or mistake or error, I corrected the solution step, giving feedback like, up to this step you are correct, but now you have made a mistake. Think, check, and do like this. I don't do it myself on the board. I just give the oral instruction, and they become very much concentrated, attentive, and they just follow the instruction that I give. And the second I can give feedback is, you are on the right track, and track towards the solution. Instead of doing this, what would happen if you did like this? Cross question during the process. What is the meaning of at least? These terminologies are especially used in set operations. What is the meaning of at least, at most, only one of them, only two of them? We can ask or some oral questions while solving the problem by a set of students. I observed that my feedback played constructive impact to solve the problem by students, and they were able to solve the problem themselves. And I got this strategy very much useful and, let's say, impactful. And there are benefits of assessment for learning in mathematics instruction. I have found that student increased students engagement in the class, improved student learning, reduced student anxiety about mathematics, and improved teacher practice also. Next one is some specific example of how assessment for learning can be used in math teaching. One method is classroom discussion. Other is formative assessment, like individual presentation, problem solving, quiz, homework assignment, group works, or some in some cases peer work also, peer teaching also. Self assessment or strength weakness analysis by each students. We can do this also. Uh, Benefits of assessment for learning in math instruction. This is continued. Enhances students' active engagement and motivation. Guides towards instructional strategies and decisions that we can make. Provides personalized feedback. Supports improving students' self-regulation and metacognitive skills. Key principle of assessment for learning in mathematics: focus on learning, not on judging. This is what I'm doing, and I think we should do it. Clear learning target and criteria for success, ongoing assessment and feedback, students' active involvement in the assessment process, promoting self reflection and goal setting, use assessment to inform and improve the instruction. Next one is action research in assessment for learning. Collect students' learning difficulties in mathematics. If possible, topic wise or unit wise, we can do this. Developed or select active, engaging, and impactful strategies for each topic, concept, or unit, with more and more examples that reinforce learning. Assess students' learning immediately in the class by classworks or guided and independent assessment, along with the feedback, not only by homework. conduct end of the chapter or unit test and provide feedback immediately, encourage students to explore the application of concept or skill in daily life. Teachers' perception of assessment for learning in mathematics instruction. I have taken the reference from NCTM USA, National Council for Teachers of Mathematics. Teachers' perception of assessment for learning AFL in mathematics instruction vary widely. Some teachers believe that AFL is an essential part of effective teaching, while others view it as a time consuming and unnecessary burden. A 2017 study by the National Council of Teachers of Mathematics found that 82% of teachers believe that AFL is important for student learning, but only 58% of the teachers report AFL regularly in their classrooms. The study also found that teachers who use AFL more frequently tend to have higher achieving students. This is the key learning for me also, the same sort of learning for me also. There are a number of reasons why teachers may not use AFL more frequently. Some teachers may not be familiar with AFL or may not know how to implement it effectively. Others may feel that they do not have the time or resources to devote to AFL. Still, others may believe that AFL is not necessary for student learning. Despite these challenges, there are a number of things that can be done to encourage teachers to use AFL more frequently. NCTM recommends that schools provide teachers with professional development on AFL, that they make time for AFL in the school day, and that they provide teachers with the resources they need to implement AFL effectively. Expected quantitative and qualitative progress in AFL. First, I'm going to present about quantitative progress. Students can make significant gain or progress in their academic achievements, such as increased scores and higher ranking. Students can become more self-aware and take more responsibility for their own learning. Students can develop a deeper understanding of the content they are learning. Students can develop better problem solving and critical thinking skills. Students can become more engaged in their learning. Students can develop a positive attitude towards learning. Next one is the quantitative progress they can make. Students can become more engaged in their learning. Students can develop a positive attitude towards learning. Students can become more self aware and take more responsibility for their own learning. Students can develop a deeper understanding of the content they are learning. And students can develop better problem solving and critical thinking skills. Uh, Challenges and barriers. Uh, Assessment for learning is not the only area which has challenges and barriers. It has challenges also. Let's see what are the challenges. First one is the lack of time. Teachers often feel that they do not have enough time to implement AFL effectively. This is especially true in high stakes testing environment, where teachers may feel pressure to focus on test preparation rather than AFL. Lack of training. Many teachers do not receive training on how to implement AFL effectively. This can make it difficult for teachers to know how to use AFL in their classrooms and to get the most out of it. Lack of resources. Some teachers may not have access to the resources they need to implement AFL effectively. This could include things like formative assessment, student data tracking system, or professional development opportunities. Cultural barriers. In some cultures, there may be a stigma associated with failure or making mistakes. This can make it difficult for teachers to create a safe and supportive environment for AFL. Student motivation. Some students may not be motivated to participate in AFL. This could be due to a number of factors such as lack of interest in mathematics, a fear of failure, or a lack of confidence in their abilities. Opportunities. At the same time, I can see lots of opportunities while working in AFL. For example, we can make time for AFL, getting training on AFL. Those who are very much interested to working on AFL, they get lots of training opportunities. Uh, Providing resources for AFL, addressing cultural barriers, motivating students, and I have some recommendations and strategies for effective implementation of AFL. These are professional development and training opportunities for teachers. This may help teachers working efficiently in AFL. Collaborative planning and sharing of best practices among the teachers, aligning assessment with expected learning outcomes, providing resources and support for teachers, train teachers on how to explore alternative teaching strategies, test and implement them, and improve or update as per the requirement. Some alternative teaching strategies in secondary mathematics, teach by games or puzzles. This can be a very good alternative for teaching mathematics, secondary mathematics, maybe in lower classes also. Teach through group or collaborative work such as problem solving by rotation or roundtable solution. One of the proven and highly effective teaching strategies used by Cambridge University and Cambridge schools worldwide, peer teaching, exploration method, oral questioning or metacognition, and quizzes, online or face to face. It can be done both. Overall, AFL is a powerful tool that can be used to improve students' learning in mathematics. By using AFL, teachers can help a student become more engaged in their learning, maximize their learning outcomes, and reduce their anxiety about exams or assessment or evaluation. And this is my conclusion. Uh, I have, I feel that I should be, I'm very much grateful to Nirul sir, Ravina ma'am, and Kilnaran sir, and whole Kusur family for providing me this opportunity to present my work on assessment for learning. And I'm on the way to conduct. My action research is ongoing now, and I'm doing action research in how to minimize the math anxiety or in among the students of grade 10. Uh, and based on that action research, I have prepared this presentation. So, any query, please? I thanks a lot.
Okay, thank you very much for your wonderful presentation, Harisaran sir. Actually, assessment for learning is very much important for students to gear up their own learning. Let me see some questions if there is. Please stop presenting, sir. Stop sharing. So, ballot participants, you can ask the questions out here. Any question? Until then, I want to ask you one question. So, assessment for
Yeah.
learning, you have been using, how long have you been actually implementing this assessment for learning in your
So
practice?
I have implemented this action research for already 11 days, and within 4 days I'll complete that action research, and I'll
Okay,
be able to present that report by next week or another week.
okay. So means you are doing your action research and the activities that you have done during this action research. You have shown that one today, yeah.
yeah.
Okay, one question has come here. How could AFL improve mathematical anxiety? One question has come from Kembusa.
Okay, this I highly appreciate this question because I was expecting the same sort of questions, and I believe that assessment for learning, this in this process, if we go thoroughly in students' problem, individual problem, or group problem, or whole batch problem, I can find lots of queries or lots of anxieties, their learning difficulties, and their personalized problems. And I believe that we can address lots of their problem queries during instruction and in the classroom itself. I have found it very much effective because I have one strong proof that that student which was very inactive in grade 9, and he was not in my section or in my set, but I have found that he is now feeling comfortable in mathematics, and based on my two tests, he has done very well quantitatively, as well as he is very active in class. He tries to respond the teachers questions and teachers problems. He presents himself positively, constructively. So this is these are two quantitative and qualitative progress I can see.
Okay, so one more question is it possible? Is it possible, or how can it be effective for large size classroom?
Okay, for large size classroom, we have to plan differently, but I believe that we can do it also. The only difference is we should change the strategy, and we should change the planning. The planning for a small size class and the planning for large size class. In large size class, I think group work may be more effective. uh, Teamwork or group work may be effective. And I have one experience of conducting a workshop for teachers, like a roundtable solution of the problem. In large size, we can conduct that roundtable solution of problem.
Yeah, I think we can also use different strategies like peer assessment. Yeah,
Yeah, yeah, sure.
students can give the feedback to each other, and group work
Yeah,
also can be, I think,
yeah,
implemented there. And teacher can move from one place to another and helping students. Not only
yeah,
the teachers, but students themselves can actually learn from each other,
yeah,
giving kind of feedback. We can see this in our teaching profession as well. Knowingly,
yeah,
unknowingly, we have been using this one as well. But the
yeah,
only thing that I have experienced is that whatever we do in the classroom for this assessment for learning, that should be do systematically, I think. And we should be well aware what we are doing in the classroom, and students also should be well aware what they are doing regarding this learning mathematics. So when
yeah,
students practice mathematics in pair or in groups, how they are interacting to each other, and how they are giving some kind of feedback to each other. That also matters.
yeah.
In that
Sure,
case,
sure,
teacher can
sure.
facilitate learning. So
Yeah,
that can be some kind of strategies we can use there.
yeah, sure, sure. Oh,
We
well, we
can
can do
use
that.
in case of
Yeah,
in case of summative assessment. Yeah,
yeah,
assessment for learning can also be used, I think, like using portfolio, yeah, portfolio, and different classwork diary, etc., etc. Reading these all classwork diary and portfolios, teacher can call a student and discuss with him or her personally,
yeah,
and give the feedback, so that there will be some kind of learning for students, and that may
yeah.
help students to reduce their anxiety of mathematics, maybe, so far. But I don't know what your action research will give out as outcome, research outcome. But so far as my understanding, through the literatures and my practices, during the time when I was teaching mathematics, I have used unknowingly this assessment for learning. I realize now. So that's what I have to say. Okay, thank you very much, Harisaran sir, for your wonderful presentation. It's already time. We can
Yeah.
see in next Friday. Thank you very much.
Okay, okay. Thank you, Indra sir, and thank you whole Kusud family for providing me this opportunity. And I would be expecting another presentation very soon.
Okay, thank you very much. Sure.
Yeah, yeah.